All right, here we go. Last lecture in this class before spring break. I don't know about you guys, but I am super excited. Yes,
Okay, so spring break, you won't come to class Monday or
you don't come to class next week. I mean, you can, but I won't be here because I will be, I don't know what I'm going to do. I'm just so excited about it. All right, so today we're going to cover Module 13, which is a sandbox only module. So there's no assignment 13, just a sandbox. And this is going to cover a concept that might be interesting to you, but if you're not majoring in computer science or going further into coding, you probably won't ever hear about it again. But you'll recognize it when you see it, and maybe you'll be like, oh, I remember learning about that. That was interesting. Um, Following Module 13, when we get back from spring break, we've got what I would probably consider the two most challenging modules in the class. 14 and 15 will cover something called object-oriented programming. They will challenge many of you, but it's important to understand object-oriented programming. And so we'll get into that for those two modules. And following Module 15, we've got three modules remaining in the class. Those three modules are what I sort of refer to in my mind as the fun modules, because in those modules, we'll be working on three different projects that use advanced libraries and modules in Python to do some things that I think are more fun and creative. And there's a lot of, in those last three projects, there's a whole bunch of creative leeway there for you to kind of do things that you think are interesting. And so they're kind of fun. They are a little bit more advanced, but it's sort of, you can take it as far as you want to go kind of situation. So in those last three projects, we're going to be doing an image filtering program. So we'll be building filters like you would see on Snapchat or Instagram from scratch in Python. The next one will be a graphical user interface assignment where we will take a previous project from the class or anything you want to and build a graphical user interface. So in other words, instead of interacting on the command line, we'll actually be using things like windows and buttons and clicking and all of that stuff like you would expect from a modern day program. So that'll sort of connect, this Python world of the command line with stuff that you're used to seeing on a computer, which is kind of interesting and fun. The last project will be to build a video game from scratch using a library called Pygame. So those are the last three. I think they're really fun, and then the class will be over. So I think as soon as we come back from spring break, it's going to be kind of a mad dash to the finish line. Probably, I think there's 5 weeks after spring break, maybe 6, but it's going to go by real quick. So all that to say is, let's get into recursion. And recursion is sort of one of those computer science concepts that gives a lot of people trouble and when it comes to sort of wrapping your mind around what it means and what it is. We see recursion all the time in the world. This is an example, it's a visual example of recursion. Does anybody know what this is called? A fractal. It's called a fractal image, and it's a computer-generated image. And you can kind of see what's going on here. If you look closely, you can see that the whole thing kind of makes this spiral shape. It is the golden ratio if you're attuned to that sort of thing. But if you look more closely, what you'll see is that that spiral shape is repeated inside itself. So you got the big spiral here, and then inside this, you've got these smaller spirals going. And if you zoom in really close in just one of these smaller areas, what you're going to see is more and more spirals that decrease in size. So the shape is repeating itself at smaller intervals. Now, this is an artificially created fractal image using recursion. This is Romanesca broccoli. it is one of the many examples of recursion that occurs in nature, which I think is super interesting. Now, I've never actually had this to eat, so I don't know if it's good to eat or not, but it sure is fun to look at, right? So you've got these cone shapes, and inside the cone shape, it's made up of smaller cone shapes that are the same proportions. And if you look really closely inside those shapes, you see more of the same shape repeated inside itself. Nature uses recursion all the time. There's just something efficient about it, I guess. Here is an image that I created using recursion. And you can't really see it much there, but this tree, it's got multiple layers. But if you look at this front layer here, it's a tree where the branches go a certain distance and then it splits 4 ways. And every time it goes a certain distance, it goes a little bit shorter distance. So this is the longest, this is a little shorter, this is a little shorter, and a little bit shorter even. But every time it splits the same 4 directions. That's a recursive shape. But what is recursion? What is it? Well, we talked about repeating a shape inside itself, but how do we create recursion? Have you ever seen this movie before, Inception? You know, they say it's like a dream inside a dream inside a dream. And I don't know if you watched the movie. I don't know if you actually could wrap your mind around what was going on in the movie. I struggled at points. But this is an example of recursion. when they go to sleep and they're inside the dream, and then inside the dream they go to sleep, right? And then they go to sleep again inside that dream, inside the dream, inside the dream. And then when they're finished with whatever they're doing here, they have to like wake up, right? They have to come back out of those dream states multiple times. That's a great example of recursion.